Hello students and friends. First of all, Happy New Year to all of you. In this video, I am going to present a presentation on basics of solar energy and solar photovoltaics. So if you are having an idea to switch over to solar, I hope this video will be helpful to all of you. So I can say that if you are going to solar, you just see this video. After that, you can decide on which one we can go and all. So the talk of the title of the present talk is "Want to switch to solar." Okay. So whenever we are coming across the presentation on solar energy and its utilization, we used to come across one question that is have you ever used the solar? Okay, have you ever used the solar energy or solar directly? So most of the time we used to say the answer is no, but mostly we have to tell that the answer should be yes. Okay, because for human evolution and also the day-to-day life, the solar energy is the important one, right? So without solar energy, we cannot do anything on the earth, because solar energy is the source of all energies, right? Primary source of all energies. So now what do you call that solar energy, right? Solar energy is the energy that directly comes from the sun, right? So sun is a source of energy. I already told you. Sun is producing two types of major energies. One is heat and light, right? So we can directly harvest the heat or sunlight from the sun itself, right? So first, here one example I have given to you, that is your photothermal energy harvesting system. Okay, so here two parabolic reflectors are there. That reflectors will reflect the heat energy, and exactly at the point, exactly at the focal point of the parabolic reflectors, we are keeping one perfect absorber, a vessel which is made up of perfect absorbers, simply the copper. Okay, so the heat energy is going to be fall on this particular parabolic heat reflectors, heat concentrators, and it is going to be concentrated over this particular perfect absorber, right? So here if you want to heat any substances or your food or something, you can keep it in that vessel and you can heat it, right? So direct energy utilization, direct thermal energy utilization from the solar energy itself, right? So next here, this is all of us know that it's a solar water heating system. So here we are using the sunlight to heat the water, right? So here sunlight is going to be absorbed by some material, and it is going to be converted into heat energy, and that heat energy is going to be used to heat the water. Okay, so here it is direct heat utilization, and here it is sunlight is going to be converted into heat energy. That heat energy is going to be used to heat the water or something, right? And third one important thing is solar photovoltaics, right? Solar photovoltaic means solar electric, you can call that as and here we are going to use the sunlight to produce the electrical energy, right? So here sunlight is going to be falling on the solar panels. So solar panel, which is a system which is converting the sun's light energy into electrical energy, right? And we need to have one inverter. That inverter is needed in our country, because here we are using 230 volt AC lines, right? So but solar panels will produce DC voltages itself, right? So we have to convert the DC voltage to AC voltage. So we need to have a inverter, right? So primary part of a solar photovoltaic system is your solar panel and solar inverter, right? So that solar inverter, the output of the solar inverter can be feed to your house or your grid. So based on your needs, you can have this particular inverter, right? So I told you, for the solar photovoltaic systems, your solar panels and inverter, both the things are needed. And if you are coming to the solar panel, the solar panels are nothing but the photovoltaic panels. Sometimes it is going to be called as the PV panels also, right? So based on the crystalline purity and also the efficiency, the solar panels or PV panels are going to be divided into two types, mainly two types. One is monocrystalline panels, another one is polycrystalline panels, right? So what is the difference in between them means, monocrystalline panels are going to have somewhat higher efficiency than the polycrystalline panels. So since the efficiency is very high and also the technology is somewhat advanced technology, the cost is also going to be a high one, right? So in the polycrystalline panels are going to have some less efficiency, so that the cost is also less, right? And the electronic control and the conversion devices, mainly the inverters, right? So mainly the inverter. Sometimes we don't need to have an inverter. Sometimes if you are going to directly use the DC itself, you need to have a charging controllers also, right? So generally we can call that as a electronic control and conversion devices, right? That conversion devices are of mainly three types. One is on-grid inverters, another one is off-grid inverters, another one is hybrid inverters, right? So these three things are only the inverters I have given here, means DC voltages are going to be converted into AC voltages itself, right? So that's what I have given here. So on-grid inverter means the grid, your electricity board, which is giving you the electricity power to your house. So that particular grid is itself going to be act as the storage. And here for the non-grid inverters, we don't need to have a battery backup, right? So we don't need to have a battery backup. Daytime, the produced energy is going to be transferred to the grid, and in the night time you are going to use it, right? So grid is going to act as a storage system, right? So excess energy is going to be exported to the grid, and in the night time it is once again going to be imported, right? So these are called on-grid inverters. But each and every devices are having its own advantages and disadvantages, so we are going to see it later. Next one is off-grid inverter, right? So off-grid inverter means here we are not going to give anything to the grid, right? So whatever you are producing, we are going to use ourselves, right? So since this particular off-grid inverters are mainly for our home itself, we need to have a battery backup so that we can use the excessively produced power in the night time, right? So we can use the excessively produced power in the night time, right? So next important thing is hybrid inverter, right? Hybrid inverter means that hybrid inverter will act as a on-grid and also the off-grid inverter also, right? So daytime, whatever you are producing, you are going to use it in your home, right? The excess energy itself going to be exported into the grid, and if needed in the night time, it is going to be called back to the home itself, right? But here in the hybrid inverters, we are going to have the battery backup also. So since the battery backup is also there, and grid export option is also there, hybrid inverters are somewhat higher in cost, and sometimes it is not advised in some of the electricity boards, okay? And the next one is there, that is your retrofit systems, right? Retrofit system means already you may have some inverters or UPS in your home, right? So in addition to that inverters, you can have a charge controllers itself, so that already exist inverter itself can be converted into a solar inverter, right? But the retrofit inverters are not advised to be used. I'll tell you the reason why we cannot we should not go to that retrofit solar inverters, right? So in mainly commercial point of view, solar panels are having two important types. One is monocrystalline and polycrystalline. So and in your inverters, they are having three types. One is on-grid, another one is off-grid, and the third one is hybrid. I told you already the retrofit systems are not advisable to use, okay? And before going to the deep insight, we need to see why we need to switch over to the solar, right? The reasons why we need to use to the solar. The first thing is to avoid the climate change and in its impact in the your day-to-day life, right? So for example, the temperature in Siberia have been more than 5 degrees Celsius above the average from January to June 2020. And in June, up to 10 degree was there above the average, right? So this is the last year's data. And one more, thing is also there. The Death Valley National Park, California of USA marked unimaginable 150 degree Fahrenheit in the June 2020, right? You just see this particular, climate change is mainly due to the carbon emission, right? So carbon emission is directly coming from the direct, energy producing, generators or any other sources, right? So if you are going to switch over to the solar, you can directly avoid the climate change and its impact. Next one is the solar energy will give you the clean and renewable energy, right? So relatively zero carbon emission. Why I'm using that relatively means the carbon emission here is comparatively lower than any other, energy production methods, right? And here always the energy is, available to you since the sun is there and it keeps shining every day, okay? So the first two reasons, to avoid the climate change and its impact, and it provides clean energy and renewable energy. So these two reasons are for the nation and also for the environment, and the remaining, forthcoming reasons are for you especially, right? So for you or your home itself, right? So here the solar energy utilization gives you the freedom and control over your electricity, right? So you can be the master for your production and also the consumption, right? So you don't need to rely on any other, electricity boards or, any other grid, okay? And low maintenance. So solar energy, solar photovoltaic systems are, having, relatively zero maintenance, right? So once you have installed the solar photovoltaic system, you can forget about it, right? So relatively less maintenance is there for the solar energy utilization, right? So maybe the maintenance what you are going to do is maybe monthly twice you have to clean the panels, right? So to avoid the dusting over the panel, right? That is the only maintenance thing you have to do with the solar panels, okay? And you can operate anything on the solar power, right? So starting from your lights, fans, ACs or water pumps, you can operate anything on the solar energy, solar power itself, right? And mainly you can save some amount on your, electricity utility bill, okay? Electricity utility bill, right? So in all scales of installation, right? So whether it your, solar photovoltaic installation is small scale installation or large scale installation, you can save some amount on your solar energy installation, okay? So here I have given how you can save some money from your solar installation. For example, you just think you are user of 550 units per billing cycle, right? 550 units per billing cycle. For example, in Tamil Nadu, your billing cycle is for 2 months, right? 550 units means you have to pay at least 2,110 rupees. This is for domestic, right? Domestic means your house, for your houses. If it is a commercial line, for the minimal contractor load of 12 kVA, so you have to pay at least 6,336 rupees, right? For example, this is for home and this is for shops, small shops or workshops or something like that, right? Which use the 550 units per billing cycle, right? So for example, you are not going for full 550 units from the solar energy. You are going to have a minimal installation for example 200 watts panel or 500 watts panel, like that. Means here one advantage is that you cannot simply cross the 500 unit, right? For example, grid alone you are going to take 400 units. So if the 400 unit is crossing 500 units, the billing will be very high, right? So 400 units means you will be paying 830 rupees itself, right? If it is 500 units means 900 rupees, right? But if you are crossing the 500 units means you have consumed 501 units means you have to come to this particular 1950, something like that, right? So for one unit you will be paying 1000 rupees, something like that, right? So if you do not want to cross this particular 500 line, you can have a minimal installation. Maybe from that particular solar, you can produce simply 150 units per building cycle, so that it cannot cross the particular 500 unit limit. Okay. So in that case, you can save 1280 rupees, right? So for the whole 550 units, you can save 2110 units, and for that particular 150 units alone means it is 1280 rupees, right? So if it is a commercial load, you just see the saving is once again 1200 to 200 rupees itself for the minimal solar installation. But if you install the solar panels for the whole 550 units per building cycle, you can save 6,336 rupees per building cycle, right? So this I have I have taken from this particular TNEB website, which is electricity board in Tamil Nadu. So here for this particular solar installation, we will be fearing about the initial investment on the solar panels, right? Because it will be in the lakhs or something like that, right? So here I am going to tell you, we don't need to bother about the initial investment, because whatever you invest, you will be taking back in a 4 or 5 years itself, right? So that I'm going to show you in a calculation, right? So here you just take the previous example itself. We are going to use 550 units per building cycle, right? 550 units per building cycle, right? So if it is your load is your commercial load, so you will be paying 38,000, roughly 38,000 per year, right? So 6 building cycle, 6 building cycle means 38,000 per year. Okay. So and if it is if it is domestic, you will be paying 12,660 rupees per year, right? So domestic means 12,000 rupees, commercial means 38,000 rupees per year. And for 550 units usage, you need to have at least 2 kilowatt solar system, right? So 2 kilowatt solar system will produce 12 units of energy per day, right? So 12 units of 12 units of energy per day, right? So this particular 2 kilowatt system commercially costs around 1,30,000 rupees nowadays. So here, if it is a commercial one, right? So if you are going for commercial installation, you can take that particular 1,30,000 rupees in 3.5 years alone itself, right? 3.5 years, you'll be taking back the initial investment, because per year you'll be paying 38,000, roughly 40,000 means 40 into roughly 3.5. If you put 40 into 3.5, it will be coming 1,30,000, right? So within that 3.5 years, you will be achieving your initial investment, right? So remaining 25 years or 30 years for you just see for the commercial remaining 26 years, your energy is going to be a free one, right? So energy is going to be free one, means you will be having in your hand, right, roughly 10 lakh and 7,000 rupees as a savings without interest. This amount is without interest. If you add some interest to it, you just imagine about the savings, right? So if you if you invest 1,30,000 rupees at the end of that 30th year, you will have 10 lakh rupees in your hand, right, as a saving, right? So if it is a commercial, if it is a domestic usage, you just see within 10 years your initial investment will be repaid, right? So 10 years means per billing cycle you will be paying 12,000 rupees, right? So 13,000 rupees, around roughly 13,000 rupees. So 13,000 into 10 years means 1,30,000 will be coming, right? So 1,30,000 will be regained in 10 years, right? So remaining that 20 years, your energy consumption is going to be a free one, right? So if you calculate the electricity bill for that particular 20 years, that is coming around 2,53,200 rupees, right? So once again, this is also without interest. okay, without interest. And out of this particular 2,53,000 or this particular 10,07,000, maybe you will be changing the batteries 2 times roughly, right? So changing the batteries for 2 times means roughly you'll be spending not more than 50,000 rupees, right? Not more than 50,000 means here you will be having 2 lakh rupees in your hand, and here you just see you will be having 9,50,000 rupees in your hand, right? So investing in solar PV system is more profitable than investing in gold or shares or fixed deposit, etc., right? So investing on solar energy will give you high returns on initial investment, right? So I think after seeing this particular calculation, you don't have the fear on initial investment, right? And if you have some dilemma, sometimes you are okay with the previous calculation and you are ready to go with the solar installation. The next important thing is you will be coming with the one dilemma that whether I have to go to on-grid or off-grid, right? So here off-grid means I already told you it is a completely independent one. On-grid means it is a dependent one. So here we are going to see in this slide we are going to see the differences in between the on-grid and off-grid, right? So on-grid means on-grid solar installations are very cheap and very cheap. Why it is very cheap means here 2 things are there. One is government subsidy is available, right? So only for the on-grid solar installations government subsidy is available, right? For the off-grid it is not available. And one more thing, here we are not going to purchase the batteries for that, right? Since the grid itself going to be used as a battery backup, right? So because of that, we are going to avoid the expenses for the battery also, right? So it is very cheap on these 2 points, government subsidy and also the battery, right? And one disadvantage of this particular on-grid solar system is the on-grid solar system will not work on grid power failure, right? So if the EB power is not coming to your home means if there is any power failure, the on-grid solar system will not be working, right? Because most of the time on-grid inverters will be synchronizing the frequency of synchronizing the frequency and power of your grid power, right? So if the grid power is failing, the synchronization is going to be missing, so that the on-grid inverters will not be working, right? So here, if you are going for the on-grid inverters and in that time of power grid failures, you have to have one UPS or generator backup for your home, right? So whatever may be the case, whether you are going to have the on-grid inverters or off-grid inverters, you need to have a backup system, right? So for that UPS, you need to have a inverter and battery and all, right? So because of this particular reason, I suggest you to go for off-grid installations, right? So here, off-grid installation, the government subsidies will not government subsidy is not available for the off-grid installation, and the cost is also 25% more because the battery cost is involved here, right? So here, you don't need to bother about this particular 25% of increased cost, because here in the off-grid system, the off-grid system itself going to be act as a UPS itself, right? So it is not bothered whether your grid power is available or not. The off-grid system is going to give the power to your home, right, all the time. So here in the on-grid, you may have one UPS or generator backup, right? So here it can be avoided. So this particular 25% of excess cost is going to be avoided by the UPS backup is missing here, okay? And here in the off-grid system, you can be energy independent, right? So you don't need to rely on the grid power failure or excess voltage or over voltage or under voltage surges present in your grid power, okay? And I already told you the battery replacement cost is same in both the on-grid and off-grid system. On-grid system will not use the battery backup, but in the on-grid system will not be working on grid power failure. So on that time you may have a UPS as battery backup. So that batteries present in your UPS or generators needed to be replaced, right? So no matter whether the battery is used or not, right? So 5 years or 7 years, you have to change the battery, okay? So we don't need to bother about it, whether it is used or unused. You have to change it each and every year, right? So that is the life of your battery, okay? So in off-grid option, the grid power can be surrendered, right? So since we are, energy independent, or we are independent of your grid power, we can go for, grid power surrendering, okay? So we can surrender the grid power, okay? And new house builders can save the cost of getting new EB lines, right? So roughly 3-phase, EB connection means you have to pay at least 30,000 rupees, right? That cost can be, saved, so that cost can be, invested in any of the, panels, or more panels or more batteries and all like that, okay? And here, I told you one thing, so we don't need to go for retrofit system, right? So why we don't need to go for retrofit system means, here, this is what the connection diagram of your retrofit system, right? So solar power is directly coming to the charge controllers. Here it is not alone a charge control, it is going to give the load to your external thing also, right? You just see here from the charge controller, you just see it is going to be batteries are going to be directly connected, right? So charge controller is going to directly control the charging of the battery also, and it is going to give the power to the load also. Here your inverter is a load, right? So already present inverter is a load, right? So here some problem will be there in the charging of the batteries, because nowadays modern chargers are having some special type of charging mechanism which can enhance the battery life, right? So normal inverters is giving you 5-year backup, means the same battery will give you at least 7-year backup in modern inverters, right? Because they are using some special type of charging mechanism, right? So here you just see to charge the battery at least 6 hours is needed, means first 3 hours it is going to be, what is that, the battery is going to be charged by constant current. You just see constant current is going to be given for first 3 hours, right? So that time battery voltage is not going to be controlled. Constant current charging. After that you just see current is going to be decreased, and it is going to be reaching up particular smaller value, right? So after this particular 3 hours to 6 hours, 3 hours to 4 hours or 5 hours, the voltage should be maintained as a constant one, right? So after that, for example, at this particular 6 hours, the charging is complete, means the battery should be given with some small amount of current, maybe some 100 milliampere or 200 milliampere itself, right? So in that time, so the battery, electrolyte will not be, lost, or the your sulfation will not be happening in your battery, right? So if you do the charging like this, right? So for example, in this case, in this retrofit case, no constant current and voltage charging is possible, okay? Because the load is also connected to the battery, right? So sometimes it will be the for example, the during the charging itself, you'll be using some more power, right? So that time more power will be derived from the battery itself, so that battery charging will not be having this particular charging profile, right? So because of this over voltage, the battery will be sometimes charged with over voltage or over current, or less voltage or less current, something like that, right? So less voltage and less current will not be a problem for this, but the over current and over voltage will be a problem for the battery charging, right? Because the over current leads to the sulfation, right? Sulfation means after 1 or 2 years, inside the battery you can see some black colored, some deposit over your, floaters or the wall of the battery and all, right? So that is called sulfation, right? So sulfation will lead to the heating of batteries, right? Heating of battery. And over voltage, over current leads to sulfation, over voltage leads to electrolyte loss, right? Electrolyte loss means water will be easily lost inside the battery. So you have to refill the electrolyte each and every month or 2 months or 3 months like that, right? But if you are charging the battery with the constant current and constant voltage, like by following this particular profile, you can avoid the sulfation in the battery, so that the life of the battery will be increased, and the electrolyte loss also will be very less, so that the maintenance will be very less. Okay, so this particular controlled voltage and controlled current charging will not be available, will not be possible most of the time in your retrofit system. That's why I'm saying retrofit systems are not advisable to use. Okay, so next thing is your solar panels, right? So which solar panel I can go, mono or poly panels, right? So here monocrystalline panels are somewhat higher in efficiency compared to the polycrystalline panels, right? So once again, monocrystalline panels and polycrystalline panels both are having its own advantages and disadvantages again. So that's what given here, right? So monocrystalline panels are having 20% efficiency per unit area, right? So here the efficiency should be always given in this particular unit, means efficiency per unit area, right? So 1 meter square area means this is what the efficiency, right? So if you are increasing the area, the efficiency will be somewhat high. So always the efficiency should be called in this way, 20% efficiency per unit area, right? So for example, if you are purchasing one panel having 330 watts, right? 330 watts mono and 330 watts poly, right? So what would be the difference in between them? Means 330 watts of polycrystalline panel and 330 watts of monocrystalline panel, both will be giving you the same current and voltage itself. Then what will be the difference? Means monocrystalline panel, the same 330 watts of monocrystalline panel will be somewhat less in the area, right? Area will be somewhat lesser than the polycrystalline panel. That is the main thing, right? So that's why I told you 20% efficiency per unit area, right? So here this is the advantages of your monocrystalline panel, monocrystalline solar panel. And here next one more advantages in your monocrystalline panel is this particular monocrystalline panels will work in low light condition. For example, in the early morning and in the evening time, right? So the late evening time. So that time the light conditions will be poor. In that poor light condition also, it will give you some better performance, right? Monocrystalline one, right? And here two disadvantages are there. One is high thermal coefficient is there for the monocrystalline. Because of the high thermal coefficient, monocrystalline panels will be less performing in your higher heat areas. For example, per degree Celsius increase in the panel, the efficiency is going to be greatly decreased compared to the polycrystalline panel. Okay, so that is one disadvantages, right? So at peak sunlight, the efficiency is going to be further smaller than the polycrystalline panel. Okay, so that's why in heat areas are very high sun areas, it is not advisable to use the monocrystalline panels, right? And because the efficiency is very high, the monocrystalline panels are slightly costlier than the polycrystalline panel, right? So this is one disadvantage. So if you are coming to the polycrystalline solar panels are going to have 16% efficiency per unit area, right? So for the given area, the efficiency is going to be very less, right, compared to the monocrystalline panel, right? And here this particular polycrystalline panels work well in high temperature region, right? I told you, right? So for example, in Tamil Nadu, the weather conditions will be worst in summer, right? For maybe it will be reaching 40, 45, 46 degrees also. At that particular high temperature regions, the polycrystalline panel will work better compared to the monocrystalline panels, right? And here, since the efficiency is very less, it is a cost-effective one, right? Which one? The polycrystalline panels are. And the last one, advantages of your, polycrystalline panel is this particular polycrystalline panels are having low thermal coefficient, right? Low thermal coefficient means heat diffusion will be somewhat less than the monocrystalline panels. So the efficiency will be somewhat higher in high temperature regions. Okay. And nowadays one more new technology is coming into the play, commercial play, that is Mono-PERC panels, right? So Mono-PERC panel means it is actually a monocrystalline panel, but that particular monocrystalline panel will work in high temperature region also. Means the Mono-PERC panels are going to have low thermal coefficient compared to the monocrystalline solar panels, so that they can work well in high temperature regions also, in added to the low light condition. Okay, so the monocrystalline panels will work well in low light and high temperature regions also, and the efficiency is going to be once again high. It is going to be reaching 23% also. Okay, so based on our initial investment, we can either go for polycrystalline or monocrystalline or Mono-PERC panels, right? So in Tamil Nadu like areas, I prefer not to go to pure monocrystalline panels. Either we can go for polycrystalline solar panels or Mono-PERC panels. Okay, and what is the difference between the mono and Mono-PERC means? So either it is a mono or poly panels, the cross-sectional area will be looking like this, right? So P layer and N layer, what is that? P-type, PN junction solar cells, right? Solar cells are having PN junctions. So P layer and N layer will be there, and below this particular N layer, you will be having back surface field, and below this particular back surface field, we are having one screen printed aluminum paste. Okay, right? Some aluminum electrode will be there, right? So here the sunlight will be falling on the cell, on top of the cell here, and light energy is going to be absorbed, and the longer wavelength heat energy is going to be diffused into the cell, and it is going to be reaching the metal, right? So the metal, aluminum metal part, right? Here the aluminum is a good absorber of heat. Okay, so that they will be absorbing the heat, and the total panel will be heated again. And here in the PERC panel, what we are going to have is here in addition to the local BSF, we are going to have a capping layer and also the passivation layer, right? So here this particular capping layer and passivation layer will block the infrared radiation going into the backside screen printed aluminum paste, so that the heating of the panel is going to be avoided, so that the panels will be working in high temperature region also. Okay, that is the difference between the mono and Mono-PERC panels. And here, if you are coming across the inverters again, so we will be seeing two important technologies. One is PWM based or MPPT based. Okay, so which one we have to go means I'll suggest you to go for MPPT inverters, because MPPT inverters will give you some 30% more power compared to your PWM based inverter, right? Because here in your PWM inverters, the panel voltage should be pulled down to the battery voltage. For example, your solar inverters are going to have only one battery, means the one battery voltage is 12 volt, right? So here panel voltage, what you can use is only in the range of 12 volt itself, right? For the 12 volt battery, you have to use only the 12 volt panel itself, right? So here 12 volt panel will give you the maximum voltage of 17 volt like that, right? So the 12 to 17, that remaining 5 volt is going to be clipped off from the power coming from the solar panel, right? So panel voltage is going to be pulled down to the battery voltage, so that particular 5 volt is going to be missed from the solar panels. Okay, so here this type of PWM based inverters are largely suited for small scale integration, because some customers will be looking on some cost effective solar installation, right? So that time you can go for this particular PWM based inverters, once again if it is for small scale integration. Okay, and if it is a large scale integration, you can go for MPPT, and here in the MPPT technology, that 30% more power is going to be achieved, because here the inverters are going to be operating on the maximum power point of that particular solar panel, right? So maximum power point of the solar panel, for example 1000 watts panel means 850 watts will be coming out of the solar panel. Always that particular inverter will fix that as a maximum power point, right? So power is going to be fixed. P is equal to V into I, right? So P is equal to power is equal to voltage into current, right? So here the voltage what we need to charge the battery is 12 volt, right? So 12 volt mean, for example, 13 volt means the excess power is going to be converted into current. Okay, so power is going to be fixed and voltage is going to be fixed, so current is going to be a varying one, right? So like that, current and voltages are going to be varied by keeping the power coming from the panel as a constant one, right? So since this particular power point tracking technology is somewhat technologically advanced one, it is going to have some high cost to afford it. Okay, and here the panel voltage can be anything within the range of the MPPT. For example, I told you for the PWM, right? So for the PWM, 12 volt panel 12 volt battery means 12 volt panel alone you can use it. But for the if it is a MPPT system, for the 12 volt battery you can either use 24 volt solar panel or 12 volt solar panel. You can use it. Only thing is the panel voltage should be within the range of the MPPT range. MPPT range will be, for example, 12 volt, 7 volt to 45 volt means you can go for 24 volt system or 12 volt system, like that. Okay. So in MPPT, the panel voltage can be anything. And once again, after going through this whole thing, even after considering all the things, if you are having some dilemma again on the initial investment, you don't need to go for a package, right? For example, if you go to any solar installers, they will be providing you 1 kilowatt, 2 kilowatt, 3 kilowatt system, like that, right? So you don't need to go for that type of system. Simply you can go for your need. Okay, for example, you will be using 1.5 kilowatt alone in the daytime, means you can go for 1.5 kilowatt system alone, right? So if you are concerning about the money, okay, so 1.5 kilowatts alone. But only thing is, here the inverter should be somewhat modular one. Modular one means it can be a flexible thing, so that in future you can add some more panels or batteries to that system. Okay, so only thing is you have to purchase the inverters as a flexible one, and the panels can be anything based on your need, right? So for example, 2 kilowatt system, 2 kilowatt inverter you can purchase. In the 2 kilowatt inverters, you can either put 1000 watts solar panels, or 1200 watts or 1500 watts or full 2000 watts solar panels, right? So if you go for your need, you can once again reduce your initial investment, right? So I hope this particular presentation will be somewhat helpful to all of you. Thank you.